Welcome, this is a AQA AS physics video for June 2013, Unit 1 past paper. Now, what I've drawn on the board there, I've drawn a circuit diagram yet given in your paper. We've got a battery of 6 volts, we've got a light dependent resistor which is set at 50,000 ohms for a particular light intensity. We've got a variable resistor that's 35,000 ohms. We've got a fixed resistor that is at 5,000 ohms. So obviously very high resistance. And we've got a voltmeter that's just measuring the current, the potential difference across it. Okay. The first question asks us to find the current. Now it should be a very small current because, as you can see, we've got a very high level of resistance there. But the way to calculate resistance is different when they're in series and parallel. Because these are in series, we simply add all the resistances together. The resistances, components of resistance. We know the potential difference is 6 volts. The total resistance is 90,000 ohms because it's 35,000 plus 50,000 plus 5,000. And then we just use the equation B equals IR. We want to find the current, so it's I is equal to V over R, so therefore 6 volts over 90,000 ohms. Remember, it's 90,000 ohms, 90 kilo ohms. Even though they mean the same thing, you'll get a different answer, sort of thing, for using one of the two. So it's 6 volts over 90,000. Okay, that gets you 6.7 times 10 to the minus 5 amps. So the current, therefore, 6.7 times 10 to the minus 5 amps. Okay, so it's very small, as we expect, because it's got very low level of very high level of resistance and therefore very low level of current. Okay, so that's part A out of the way. Sorry, just a sec. Right, I thought this would easily just link onto the next thing, but my infamous tablet thing has decided it's had enough. In a sec. Let's see, friggin' way up. This thing is not the fastest thing in the world, but you know, anyway, let's go. For God's sake. I do apologise about this, but I thought this would be a good idea. Never mind, hey. Okay, so that's. One sec, I'm gonna load this up. Right, sack that. Okay, so this is question 7A part 2. Calculate the reading on the voltmeter. Now we know the current is 6.7 times 10 to the minus 5 amps, and as we said, in a series that is the same all the way round the circuit. It's only in a parallel circuit it's split up. Okay. So therefore we know the current at this R is the current we've just calculated, which is 6.7 times 10 to the minus 5 amps. Now you may want to leave the actual answer you got, which was something like 6.666 and then a couple of more 6's and 7 times 10 to the minus 5, but you could just round it to that. It's not going to make too much of a difference. Okay, obviously we also know the resistance of this is 5,000 ohms, and we want to know the potential difference on the voltmeter, which is just a case of, because V equals IR, therefore V is equal to 6.7 times 10 to the minus 5 times 5,000. Okay, so therefore the voltage is just a case of subbing them numbers into your calculator. So it's a very simple process. So this is just a case of, I mean personally I would use the actual answer you got, which was your 6 over 90,000. And you times that by 5,000, which gets you voltage to be 0.3 recurring volts. Potential difference, sorry, to be 0.3 recurring volts, or 0.3 volts because it rounds down to that. Okay? Alright, state and explain what happens to the reading on the voltmeter if the intensity of the light incident on the LDR increases. Incident light in the LDR increases. Now, when the light intensity of a LDR increases, the resistance of the LDR decreases. So therefore, if the battery is remaining at 6 volts, we're not changing the battery, the resistance has decreased, so therefore the current must have increased, because V equals IR, so if the resistance decreases, then the current must increase to compensate for that, to keep the voltage or potential difference of the battery the same. So hopefully that makes sense. So therefore we should have a higher current, and if we've got a higher current, and this resistance is the same, then because V equals IR, and we've increased the current, but the resistance has stayed the same, therefore we must have increased the potential difference over the resistor R, so therefore we have increased the voltage on the voltmeter. Okay, so the next one is another calculation question to finish off question 7. Okay, so it says, for a certain application at a particular light intensity, the PD across R needs to be 0.75 volts. Okay, so what we know is obviously this resistance at R hasn't changed. We've just changed, all we've done is change the light intensity at the LDR, but we've not been told how it's affected it. Okay, so we know that the resistance R is equal to 5,000. We've just been told that the 5,000 ohms. Sorry, we've just been told that the reading on the voltmeter at R must be 0.75 volts for whatever they want us to calculate. Okay, the potential difference must be 0.75 volts. The resistance for the LDR at this intensity is 5,000 ohms. Okay, so that's the resistance of the fixed resistor. Okay, the resistance of LDR, we are told, is 5,000 ohms. Okay, and we're asked to calculate the required resistance of the variable resistor in this situation. Okay, so what have we need to realise what we've got here. Well, we need to think first of all about the current. Now, as I said, the current in a circuit such as this, in a series circuit, is the same throughout. Now we know that the potential difference across R is 0.75 volts, and the resistance of R is 5,000. 5,000 ohms. So what we do is again use V equals IR. Okay, so subbing what we know, 0.75 volts equals the current, which we want to find out, times the resistance of 5,000 ohms. Okay, so it's 0.75 volts over 5,000 ohms gives us our current. Remember, this current is the same throughout the whole circuit, so just sub that in your calculator. So remember, it's 0.75 over 5,000, which should get you 1.5 times 10 to the minus 4 amps. Okay, alright, so hopefully you can understand where we've got that from. Alright, just using the information they've given us. So therefore you can put this in, said I is equal to 1.5 times 10 to the minus 4 amps at this new intensity. Okay, so what do we do now? Well, I made a bit of a mess of this, so I might have to squeeze this on. Okay, so we know the resistance of the LDR is 5,000. We know the resistance of the fixed resistor is also 5,000. Obviously, the potential difference of the battery hasn't changed, so potential difference is equal to 6 volts still. Okay, we know the current is 1.5 times 10 to the minus 4 amps. So what is the resistance of the variable resistor? Well, we're going to use V equals IR, but on a bigger scale, and go backwards essentially. So we now know the current is 1.5 times 10 to the minus 4 amps, as proven. We know that the potential difference of the battery cannot change. 6 volts. We've not changed the battery. So 6 volts. So V equals IR. So 6 volts is equal to the current, which is 1.5 times 10 to the minus 4 amps, times the total resistance. This is the total resistance of the circuit. This is not the fixed resistance of R, because we know that's 5,000. So therefore we just rearrange to get what R is. So R is 6 volts over 1.5 times 10 to the minus 4. This should be a big number because it's the resistance of the whole circuit, so just sub that in your calculator. Okay, so it's 6 over 1.5 times 10 to the minus 4. That gets us 40,000 ohms. Okay, so the total resistance of the circuit must equal 40,000 ohms. Now we know that the current resistance of the resistor R is 5,000. The resistance of the LDR is, we'll change this because we're on a new question now. This is 5,000 as well. So what must the resistance of the variable resistor be? Well, we need to hit a total 40,000 as we said over here. So we've got 5,000, 5,000, so we've got 10,000. So therefore the total resistance of the circuit is 40,000. And we've got 10,000 so far, so therefore the resistance of the variable resistor must be 30 kilo ohms, or 30,000 ohms. Okay, so hopefully that made sense. Sorry about it's been a bit of a throw on the board there, do apologise, but hopefully you've been able to suss out what's what, and I've tried to talk you through it a little bit as well. Alright, so thanks for watching. It's only taken me a few attempts to get through that question, but we'll see you, that is the end of the paper now, we'll see you in the next paper. Or get some good juice, coffee, whatever.